Hi, and welcome back to Programming Robotic Systems with Visual Studio. I'm Paul Party, and I'm here with Chris Howd. And we've been working on building these robots and showing you a little bit of what robotic systems are about and actually how to program them. If you missed the last module, you'll definitely want to go back and check it out. We introduced our 3 robots. We showed you kind of what they can do. And now what we're going to do is walk you through how these robots were built, how they were constructed. Chris built all of these robots from scratch. He essentially cut the plexiglass, he bought the boards, put the wires in the boards, constructed the system so that everything works together. So everything that you see was essentially built from scratch. There's no pre-assembled parts. So
we're not suggesting you do that.
Right, but it is an option. So you can kind of see how we did it from starting with nothing and then building a robot from these parts. Okay, so let me walk you through very quickly what we're going to do in this module. So first of all, we want to introduce what Arduino is to you. So we're going to talk about the boards themselves. If you don't want to if you don't want to actually buy an Arduino board, you can actually buy a clone. So we're going to talk a little bit about what clones are. And then there's these things called shields, and shields allow you to extend the power of the board itself. So if you want to do other things, and Chris will talk a little bit about what those other things might be, you might want to buy a shield so that you can extend what the board itself can do. Then we'll get to the software. This is the part that I think all you developers will be very interested in. We'll talk a little bit about how the software works. The reference libraries, we'll show you those a little bit so you can get a feel for them. And then we'll show you how you can integrate the Arduino system with Visual Studio, so you can actually program the Arduino boards right from Visual Studio, which is fantastic. You get all the power of Visual Studio, but you can program your robot using that. And then we'll walk you through a quick demo. In Arduino, the programs are called sketches. So we're gonna walk you through a small sketch, and you can see how these programs are constructed. So with that, I'm going to turn it over to Chris, and Chris is going to start to walk us through this Arduino system.
All right, okay, here we go. What's our slide, Paul? What are we talking about here? Arduino boards? What is Arduino? Hey, all right, very good. Arduino, so it's an open source standard, right? Hardware and software. If you want to get the schematic for the boards, you get that schematic, print out your own thing, do your whole thing, you make it all from scratch. Yep. Open standard, right? So it's kind of different from open source software, a little bit different, but it's the same idea, right? So then the programming language is very easy, right? It's C, C#, C++, any of those languages, JavaScript, Java, those things, easy. All right, programmable via USB, right? USB board, right? Very easy to connect. Then it's affordable. Affordable, popular, big open source standard. Lots of people using Arduino. Good community. Lots of people help you out if you get stuck. So that's nice. What else about Arduino?
So actually, I have a question. So those little boards that we showed earlier, I have one here in my hand. What does a board like this run? Like either a clone or the...
Very good. Cost. Okay. So the Arduino started around $25 or so for like an Uno, and it goes up to maybe $70. So they're pretty cheap, right? I mean, pretty affordable, as you mentioned earlier. So cost is pretty reasonable, and it's extensible through the shields, as you said. I think we're going to talk about that a little bit, but we're talking about the Arduino products right now. So I have the website open. If we just switch over to my monitor, we'll look at some of these things here. So you can see there's quite a few to choose from. And this is showing us both the boards and the shields, and you can get a kit. It's nice. There's lots of other kits that you can get as well. We're using the Arduino Uno, and we're using one down here a little bit further. It's I don't see it actually, but it's 2560. There it is down there. You got these lily pads. You got all kinds of stuff, right? The ones that are different, let's see, like this Explora, there's a few different things that are set up that aren't pin compatible. They're set up for something different. We also have the Mini and Micro. Those also go for like breadboarding. And we have the Yun here, which has Ethernet ports for connecting up to your network. All right, so that's the basic thing.
And this can look a little overwhelming when you come to a site like this. What we're going to show you later as we get into how we built the robots is how you make a decision. Which board should you buy? Yeah. Which shield should you buy? So we're going to give you some guidance on how you navigate this wide variety of options and pick one that's right for you.
Right. Very good. Let's switch back to the slide deck here. Okay, so we've talked about boards. There's clones available, so you can get clones. Paul, you were asking about price. You can get some clones that are even cheaper. You can get clones maybe even down to $15. So look around for those if you want. And then we have shields and accessories. Okay, Paul, you mentioned that you use shields to extend the capability, so that's correct. So you have some basic functionality on the board. By being able to provide boards with basic functionality, they keep the cost down, but they're extensible through the shields. So these shields add onto the top. We looked briefly at one of these boards, and you could see the little headers, they're called, with pin slots in them. So you add these shields on. You can get shields that do motor control. We'll be using those. You can get shields for communication, for networking, for audio, for video, for anything. It's huge, huge market. Then back to the slide deck again. Help me remember what we're talking about. Okay, well, let's go on to software maybe.
Let's get into it.
All right. All right. If we look back on my machine again, we go to the Arduino home. I'm getting there, I think.
Yeah, we're going to quickly look at the language reference so you can kind of get a sense of what things look like.
But for installing, there's a download site here, so you're going to go right there. You can install for Windows. I believe it's buffering a little bit.
That's right.
In any case, so there's installation for Windows. There's also installation for some of the other popular operating systems for PCs. So it's pretty good in terms of installation. Just click on it. And that will load up your programming environment, your integrated development environment like Visual Studio has, only not quite the same way. So here's the Windows installer. It also supports Windows 8.1. You see the little note here. Okay, so let's say we've installed the software, which you and I have, right? Mm-hmm. And it's just on our PCs. And then you want to know a little bit about the language, I think you were saying, Paul. So we look over here. There's a reference still on the Arduino website. We see that they provide the language reference. Now, this is going to look surprisingly familiar, Paul. All right, fine, you have some structures. You got setup and loop. These are the two main always present programming loops. In setup, you do your setup. You configure your variables. You configure your hardware. In loop, that's the main program loop. You loop through that. It loops. You want to keep that looping quickly, right, so that it's responsive. But that's where you put in your calls to your other functions, and you do your main programming. The control structures, if, else, for, switch, all these things, those are very familiar. The other syntax is also familiar if you've done any C, C# programming, JavaScript. All that looks pretty similar to what you've seen before. Same thing with the data types and constants. That's all pretty familiar stuff. There's maybe some terms in there a little bit different, but the concepts are all the same. When we get over to functions. Now this is going to start looking different, right? Because a lot of these functions are referring to hardware. Pin mode, I mean, what is that, right? Digital write, digital read. Well, I kind of get the idea, I mean, I understand digital. It's kind of like binary, right? It's either high or low. Then analog, okay. Voltage, right? Analog voltage. Then you get this pulse width modulation, PWM. That's one of the things we'll be doing. We're going to use that to control our servo motors. We're going to skip past this. It says it's for a board that we're not using. Some advanced I/O, tone, no tone. I'm thinking that's some sound, right? Some time functions. I mean, we get those, and then some math functions. That makes sense. Random number is okay. Nothing crazy there. Interrupts, external interrupts. Now, in our programming, Paul, we use interrupts all the time. Sure.
And
that's what we do. So now here we only have two. So that tells you something. So now it changes the style of the programming a little bit. Communication, serial and stream, that sounds familiar. Keyboard, mouse, okay. So that's pretty much the language reference. Let's go back again to the slide deck, if you would.
Yeah, the thing that I like about the language reference and looking at that is that it doesn't seem like it's way out of what we're used to programming against. Obviously every environment has its specific things that you have to know about. The syntax is very specific to that environment, and you'll see that with the Arduino. But it's not like you're having to learn something brand new. So if you've done some procedural programming, you programmed in C# or C++, even JavaScript, all of this should look very familiar, and that's comforting, right? It's nice to know
that's a good thing.
Right in.
It's a good thing. Yep. Okay. So now, now we're going to talk about Visual Studio, right? Because we're using Visual Studio with an add-in, which is called Visual Micro. You can get free versions of both. So the Visual Micro requires that it not be the Express SKU, but there's trial versions of Visual Studio that you can use, and we're going to use. Well, actually, we have our own paid versions, but the trial versions will work just as well. So we're going to use those. We're going to jump right in, maybe, I think, and start showing Visual Studio.
And Visual Micro is a Visual Studio add-in, correct?
That is correct. It's an add-in, yep.
Which you can install from the Arduino site.
Yeah. Pop open. So we're popped open in Visual Studio here. I have it open. But Paul, could you just make sure that we're on track, that we didn't skip anything? Was this our next step?
It is our next step.
All right, perfect. All right, so here I am. What am I going to do? I am going to create a new program. What do we want to do, though, Paul? For our first demo, we're gonna rotate a servo.
Yes.
We are, and we're going to read a switch, I believe.
That's right.
All right, so we're gonna, a lot of times you'll see the blinking LED first demo, but we're jumping right in. We're jumping right in, Paul.
Yeah, I think you wanted to show a little bit of how the environment looks in Visual Studio, so let's do that first, and then we'll jump over to the first.
All right.
First sketch.
So here we are, Visual Studio. I see now that I can select a Arduino board. Okay. I'm going to check the Arduino Uno. I'm going to see where it's configured. Hey, there it is. Great. That's what I want. Visual Studio, we have the menus up here for File. Let's say File, and let's say New, because we're going to create a new one. Nice enough here. We say a sketch project. That's great.
And all those options show up once you've installed Visual Micro, correct?
Correct.
Okay.
Yep. Visual Micro is the add-in that provides support for the Arduino systems. All right. So we can just call this test 05. I think that's a safe name. Say OK. And what do we get? All right. It takes a second. All right. So we see, OK, here's that setup we talked about. And loop. Okay, very good. Now, we are going to, add a couple of lines up here, Paul. When I go up here, now I'm in a global scope. So that means that these variables I define up here are globally scoped, right? Which means they're accessible from anywhere. So I'm going to add a couple. I'm going to say, let's see, so we're doing, we're going to control a servo, and that's controlled off a pin. So I'm going to say int pin servo. All right, great. I'm also going to say
before you keep going, can you make the font just a little bit bigger for our viewers? I think they might not be able to see that size.
Every time I open this up.
Yeah, that's perfect. Okay, great.
All right, very good. Thank you, Paul. All right, then we're going to do int, let's say servo speed, because we want this thing to, let's spell that with in the English language. You know what, Paul? We need something. We talked about the language reference. Arduino also provides us with a library. We didn't really talk about the libraries, but we have libraries. And we have a library that will help us with the servo motors. So we say include. You might be familiar with doing this in other programs. Say include now IntelliSense here with Visual Studio, kind of nice, right? We see all the Arduino libraries. Now, it's a long list, Paul. You can kind of tell from looking at this. But if we start typing in servo, hey, look at that. Finds it for us. We hit the tab key, and we say, OK, there's the one we want. I scroll down, say that. All right, good to go. We see the color changes for us because it knows it's there. All right, and now we have our servo library.
Now, how did you know you needed the servo library?
Well, because I've done this before.
Yeah.
So no, but what you can do, let's switch back then. Let's switch back to the Arduino site.
Right.
And we see this thing up here, libraries, right? And we're going to see some of the libraries.
And again, this all depends on what you want to do with your robot. So we knew that we were going to drive a servo, so we used the servo library to do that. And that's just becoming familiar with the environment and with the language.
All right, so let's see. So now there's a bunch of different libraries here. Now these libraries are written in C++. You might have seen the extension .h, right? Which is pretty standard. So C++, and you can write your own libraries. I guess that was what I was going to say, Paul. You can write your own. But they provide a bunch of them for you, and they also provide some of the third-party libraries available here that they think are really good and they've seen work well.
That is fantastic.
All right, so, Ethernet, we understand that. Liquid crystal is a display of some kind. Here's servo, right? We know we want that one. You can do a different type of motor. We haven't talked about that yet. But let's go ahead. Let's look at servo since we're here.
Right, just to get a sense of what the library does, and then you can figure out whether you need it or not.
All right, here's the functions. Attach, I don't know what that does. I really do know what that does, but you guys don't know what that does. Write microseconds. So, okay, attach. I'm going to take a guess, Paul. I'm going to say attach helps us connect to the hardware.
Yeah,
I'm going to say write is, sending a message to it. Read is going to read from it. Attached and detached. I guess attached would tell you whether it is attached or not. And then detach would detach it after you've attached it, right? So anyway, a bunch of different things. They have some examples here. We're not going to look at those. We're going to switch back over to Visual Studio. So right before we do that, attach, write, microseconds. I'm going to have to remember these things, right, Paul? I got to remember it.
I think
you don't
Visual
think?
Studio may help you.
Visual Studio.
We love Visual Studio.
All right, let's see. All right, let's go ahead and build this. I just want to make sure. I saw that these. Well, we'll try it without. We'll just see. Yeah. We'll see how good this is.
Throw caution to the wind. Why not?
Sometimes I build it at the beginning just to make sure my external references are really loaded.
I do that all the time.
Right. But let's try this. Let's say servo. All right, it found it, and it uses color. So now, but what do we do? What are we going to do here?
Hit the dot.
Let's build this project, Paul. Let's try that again.
Actually, you need to create an object, right? You have to instantiate an object first.
Oh, Paul, you're right. What am I doing?
That's why
I was setting myself up to fail there. All right, servo, right, servo, my servo.
Now you're going to get all the.
Oh, good. All right, now we have that. So now we have our pin for our servo. We have servo speed. I know that we want to have another one. Let's have int servo stop, because we do want to be able to stop it. And anything else, we got the pin, we got the speed, we're going to be able to stop. I think that's good for now. And so those are our variable types. Let's go into setup, because this is where we're going to configure these things. Let's say we called it my servo. Let's say my servo. Hey, there's our IntelliSense again. Select that now. There you
get all the fun
like
stuff.
You said, Paul, I was just confusing myself.
Right.
All right, and we're going to attach. We can make sure that's selected, and tab to get that. And what do we attach? All right, again, it helps us out here, and we're going to use an int for the pin. It tells us we want our pin. So let's start typing pin, and we get pin mode, which we don't know what that is, but we see pin S is pin servo. That's our variable. We're going to use that one and put our semicolon there. Okay, so now we're attached to our servo. What else do we need to do? We need to assign some values to that pin. We didn't do that yet.
So the pin is actually the physical pin on the board.
That is the physical pin. Yeah. That is.
And so
it has a number.
The board is a number. All the pins have a number, and you just look at whatever number you plug your servo into, and that's how you attach. So it's all fairly self-explanatory, which is really makes it really easy to get started.
So I'm signing it to pin 3, and I think that's what I'm attached to. We'll check it before we go. And we haven't really shown them a servo yet.
That's right.
So we'll take a quick second before we run this, and we'll just look at it real quick. So, like you said, you got 3 wires coming off of your servo motor, right? One is the controller or signal wire, and then you got a positive and negative voltage. So
That's right.
so we have that. So all right, so we have a pin, and we are that's pretty good for setup pin attach. I don't think we need much more there. Let's move down into loop, and this is where we're going to do the controlling. Let's set. You know what? We're gonna do another function too. We're gonna control it within another function. So let's say this. Let's get rid of this junk that I just did there. Delete that. Let's delete this. Let's come down here, and we haven't done this yet. But you're not limited to setup and loop.
Right.
You create your own functions, right? So this one is just going to be of type void. We're not going to return anything with this, so it's void, and we're going to call it run servo, and we're going to take a parameter. It's going to be an int, and we will call that speed, just SPD. Okay, and we come in here. All right, now down here we're going to use this speed. We're going to move our servo, right? We're going to say my servo, because it was up in our global space,
That's
right? So now we know that.
It anywhere, yep.
And we're going to say dot, and we have this write microseconds. So we didn't look at these functions before, Paul, but I'll tell you a little bit about them.
Great.
Write microseconds provides us with a little bit more control. It takes a range in microseconds from, well, 1,500 microseconds is the middle, and that's usually a servo stopped at that point. Then plus and minus, say, about 1,000 off of that is going to go either rotation, angular rotation, 90 degrees plus and minus either way, whether you add or subtract. Now, we're using a continuous rotation servo. If we put wheels on a regular servo, it would just go 90 degrees back and forth. They would not go very far.
That's right.
We did not pick that. So, but for a continuous rotation servo, Paul, 1,500 is stopped.
Sure.
Instead of being in the middle of the movement range,
Got it.
it's stopped, and then if we go minus, it goes backwards. If we
So-
go
so-
positive, it goes forward, clockwise.
Seconds
counterclockwise,
sounds like
whatever.
a temporal thing, but it sounds like we're moving something in space, right? So why is it microseconds?
Yeah, you know what? That comes down to the signal that the servo motors work with, this pulse width modulation. It is, as the name says, it's a pulse, and that pulse goes high for a certain amount of time within its cycle. And so that duration, while it's high, it's getting positive voltage, and the longer that signal for some of these things, it'll interpret it different ways, but for the longer duration, it's going to go faster, right?
I see. Makes sense.
So you can do other things with it. With pulse width modulation, you can use it for setting voltage on an LED and make it light. You know, there's different things. There's things that you can do.
Right.
But what we're doing is extending that pulse longer.
Or shorter. Okay,
or shorter.
That's intuitive.
Yep. Yeah, that is something. We aren't going to cover everything today, Paul, but we'll try and make sure that we kind of explain. So thank you very much for that. All right. Now we're going to say speed, right? And now we've given it a speed. All right. Not much else to do other than in our loop.
You need your semicolon there at the bottom there.
All right. I make a lot of mistakes. That's why Paul makes the big bucks. He catches them all.
I'm here for a reason, right, Chris?
Right. All right. So let's see. What did we do? We have this thing. It's called run servo. So we need to know that name. I'm just going to copy that up here. I'm going to say paste it back in. And I'm going to say here, I'm going to say, what did we say? Servo stopped? Stop. And did we assign a value to that, Paul?
We have not yet.
Whoops, I gave it the wrong one. Well, let's do this. We'll fix that. Since I gave it the wrong one, let's say servo speed equals servo stopped. All right, stop.
Got it.
Plus, let's say 200. That'll go a little bit fast, right? But we didn't assign a value to stop. That was something that we were missing here. So let's go back up into our setup, which is where we should do this. And we say servo stop equals 1500. That's the middle of our range. All right. Now, Paul.
You need a semicolon again there, Chris, in the loop. There you go. Perfect. Now, will that loop just keep looping?
That loop. So what this will do.
Running over and over?
So we'll talk about that real quick.
The program
so in our global space at the top, happens once.
Yep.
We come down into setup, also happens once.
Correct.
Loop continuously runs and runs and runs. Now, in loop, we can call our other functions.
Right.
From our other functions, we could call other functions
That's right.
too.
Sure.
But loop is the thing that's cycling.
Got it.
Yeah.
So
All right. Now, let's build this thing. Oh, that's a fast mouse. Barry's got a fast mouse in here.
That's right.
All right. Did we get any errors? I don't see any.
No.
All right.
To me.
Let's see what happens when we run this thing. Let's just say debug. We'll just say run without debugging.
All right. Let's see what happens.
All right. There it goes, Paul. I see uploading is done, and there we go. First try. Okay. Very good. All right. So now we've gone through. We've set up our pin. We've created our servo object in software. We've attached that object to our physical servo. We've given it a speed. We've told it to go. That's great. That's great. Now, we still haven't read the switch, right?
Right.
So let's see. That's Paul, so that we don't have that sound going, I am going to just quickly rerun the program with our speed at 0. So I've removed the plus 200.
Yep.
I'm going to say debug and start without debugging. It's going to go out here. It's uploading the program. It's done. Now the servo should be stopped. So we don't have to hear it.
Now, why is it still moving a little bit? Can you?
Okay. Yeah. Okay. Let's see. It's turning just a little bit. That 1500 value, right? Servos. Actually, these continuous rotation servos. They come with a little adjustment to the potentiometer in them that you can zero. So you can physically zero out that 0 point, so it would be where it is supposed to be. So this one doesn't have it quite right. So we could adjust that 1500 to get it to stop, or we could physically adjust the servo, which is probably the best way to do it. So anyway, now our next step, right? We're most of the way through this demo, but we're going to do a little bit more. We are going to add another digital pin. We're going to read this switch, and it's set up off of pin 10. We are going to say int pin, we'll call it switch. And then down here, Paul, there's another little trick. I am going to switch over here real quick. I am going to go back to language reference. Just show you a little something here. As it's taken its time to get to a language reference. Here it is. We're going to do a digital read on this, right? So let's look at digital read real quick, because there's a bit of a trick here of what you have to do. In order to hold the switch at a position, we'd need a resistor to hold it at a signal otherwise, right? So what we see here is there's a little note in here somewhere. A note. If the pin isn't connected to anything, digital read can return either high or low. It can be random.
Got it.
Right? So we don't want random. So what we can do, and now I don't see it here, but I've seen other places. What we can do is, and I'm going to switch back over to Visual Studio.
And by the way, it looks like Visual Studio jumped your font size back down, so you bumped it up to 150.
Oh, those little rascals.
Yeah, there you go. Perfect.
All right. So okay, so we have our switch. But in setup, we're going to, so we go into this pin mode. Yep. Pin mode tells us how we're going to use the pin. So we say pin mode, cap lock, don't want that. Pin mode, we got the right one. Let's pick it. Tab. and we say pin mode, what did we need? Okay, we need the pin number, and then we need another value. And what we're going to do is we're going to say pin switch. Switch. I should have named it something different. Oh, geez, I got it again. All right. WITCH, comma, and now we're going to say high. All right. Okay, so now what we're doing is we're saying that this pin mode on switch 10, which is our digital read, is going to be set. Paul, again, I'm doing it wrong. All right. Pin mode, we're going to say input.
Ah.
We're going to say input. We're not going to say high because I don't think it would understand what that meant. But we can say input. Now, instead of doing a digital read, we do a digital write. We do a digital write, set it high.
Because we're switching the mode, so that switches the mode.
Yeah, the mode was for mode.
Got it. Of course, that makes perfect sense.
Okay, now digital. And it would give us the digital read here. Here it is. And we say here now, we want to say, did I say digital read, Paul? I did.
Yes.
But what we wanted is a digital write. We're going to do a digital read, but first we're going to do a digital write.
Because we're essentially setting the property.
Yeah, we're going to write to it. Now we have the two parameters. I was like, what did I type in? I see only one parameter there. I can't set it high. All right, we say, again, pin switch, comma, high. Now high is there. We do that. Now we have a good control on that pin. Now when we go to read the pin, okay, the pin is, let's do this. I'm just going to switch it to the setting that I think is off. And now we're going to come in here, and we're going to say loop run servo with this particular speed. And let's do this. So we've said servo stop, but let's do something a little bit different. We're going to create another function down here. We're going to call this read switch, but we are not going to have it type void. We are going to give, this is going to be an int. We're going to return an int on this. We're going to say read switch. And we don't need to pass it in anything. We could pass it in a pin number if we wanted to make this more versatile, but we're not going to do that.
Yep.
Read switch. Okay. Now we do our digital read. Our digital read. And now we say, of course, pin switch. And I'll just select that.
And that's another global that you set, correct?
Yep.
Perfect.
All right, so now we read digital switch. Now if switch, so we're holding it high. If it goes low, we want to do something different, right? So we're going to look at that. We're going to say if, hey, Paul, let's set a variable there. All right, let's do a local int. Because we got to assign this read to something, right? Int, let's say switch value, I don't know. Now let's say switch value equals this read. Okay, so now we have a switch value. We assign that the digital read off that pin, and now we say if switch
You don't have
value.
you don't have a C in your value, but that's okay. I just want to make sure they're consistent. It's with.
Yeah. Oh. Well, let's.
It's all.
I'm
it's
gonna
all
fix
consistent.
it. T C C C.
All right, there you go.
C. All right, nice and easy. And we're going to say if it's equal to high. That's one possibility, right? Yep. It's either going to be high or low. If it's equal to high, then we want to change our speed. Let's say servo speed servo speed equals, and it's starting out high. We're holding it at high. We set it equal to 200 before, right? So we're going to say then servo speed equals 200. We'll just be consistent with what we had before. I'm going to do this because I'm going to have an else here as well. And so I'm going to move that in there. All right, put that in there, and then I'm going to say else. And we'll say else. Servo speed equals minus 200. So we're going to flip direction based on our switch.
In the opposite direction, yeah. And you can use that switch to turn the machine off and on if you wanted. We're using it to change direction, correct?
Yeah. You can do whatever you want, right? Sure. You read the switch, it has a value, you decide what you want to do with it. Yeah, it's very, very versatile, right? But we're just getting this concept of, you know, we're holding a pin high. We're setting pin mode. We're doing all kinds of things here, right?
Yep.
We're using pin mode to set whether it's input or output. Right. We're then doing digital read and digital write. All right, let's see what we got here. Yeah, we're returning servo speed. So up here, we want to say, instead of servo speed equals stop, we want to say stop plus, let's do this. We'll do this a little bit differently. We'll say servo speed equals, what is it, read switch? What did we call that thing?
I think it's called read switch, yeah. IntelliSense will tell us, right?
I don't know about that.
Okay.
What was it, read switch? Yes, it will if we start with the right letter.
Yeah, that's right.
Read switch, and we get that. We did not pass it a parameter. So now, instead of saying this here, we need to add that 1500, right? So it's the servo stop plus servo speed. Okay, so now we've kind of kept our code pretty much the same. We're setting servo speed off of read switch, and then we're adding our middle range to that before we run it. All right. I think we have most of what we need here. We've got our pin mode off a pin, and I am just going to look and see what pin number we assigned that. We did not assign it a pin number. We always got to give them the numbers. Pin switch, right, equals 10. All right, Paul, I think that is going to do it for us.
Right.
Let's see what happens.
If it compiles.
We'll rebuild that, see if we have any errors. We don't have anything yet. Let's try and go ahead and run without debugging. All right. Now, okay. I don't remember which way it was going before, right, Paul, but
if it switches them, you know,
I'm going to pretend that that's the same way.
That's right.
And now, though, I'm going to come in here, I'm going to reach in there, and I'm going to flip that switch. Oh, and look at that, it's going the other direction. So that really is it. That's our lesson here, right? We packed a bunch of stuff in here, but we're controlling a servo motor.
That's right.
Didn't take much code, right, to do that. We're using the library. And then we're reading this digital pin, a switch, connected to a digital pin. We're reading that. We're getting the value. It's either high or low. We're using that high or low. We're checking it, and we're changing the direction of the servo. There we go.
And because the program's in a constant loop, it's going to constantly look for the value of that switch. So the reason that it's detecting that we made the change is because we're constantly reading the value in that loop function.
So if we switch it back, it's still running, right, Paul? So we switch it back. We'll just switch it a few times just to show, you know, it wasn't a trick.
That's right.
Right? It's running that way. It's running that way.
And because it's in that loop, it's constantly detecting the value.
And the loop is nice and quick. That's what you want. You want because you want the response to happen very quickly. So there we go.
That's it.
I think that concludes that demo, Paul.
Great. We just had one quick slide, just in review. We wanted to make sure that we talked about what we talk about what we talked about.
Right.
So remember, Arduino is the popular open source standard. Robotics hardware, you can get into it for very low cost, and it's fairly easy to program, as we tried to show you here. And then if you think about the programming model is very similar to other types of programming that you probably will have done. So it's not like you're having to learn anything new. You can get into this for very little money and very little time.
Yep, very good. All right, Paul.
That was a lot of fun.
I think that wraps up Module 2.
Module 2. Yes.
All right, we'll be back with Module 3.
3 in a bit.
All right.